How you doing, guys? So today I'm going to show you the process that I've taken to connect two Seplos batteries together with the version 3 BMS. What you're going to need to start off with is obviously two batteries. I have the Seplos Mason 280 litre vertical kits. Each of those is around about 15 kilowatt hours or 15 units. You'll need some lugs. You're going to need some cable. I got this battery cable from Amazon. This is 4 AWG or 25 mil square. I've already cut the black one to size here. And you're going to want to make sure that the cable lengths are the same. Now I've set these at about 1.2 meters or 4 feet. And that'll give me plenty of extra space should I need to rearrange these cables, and just cut like so. After you've cut those, you can score around here with a blade and take off what you need. Now, unfortunately, I seem to have misplaced my cutting knife. So I do have this little conduit cutter here. So it has a nice sharp blade here that I'm going to be able to use. So I'll use that. It's probably actually a little bit safer. I'll have a bit more control. And you're going to take the end of the cable that you want to put your lug. All you're going to do is measure up to where you want to cut. You're going to want to bring it right up to the edge here. All right, if I can just get that to zoom in a little for you. Okay, so you're going to bring it right up there, and nice and carefully you're going to mark right at the edge of where it needs to be. So there we are here, and I'm just going to make a score mark here. And now I'm just going to twist the cable around and let that bite into it. And back the other way. And that's it. Making sure not to cut straight through to any of the strands. You don't want any of your copper cable to be damaged. Now, when you're taking this off, I'd recommend you give it a little bit of a twist, so the strands stay together relatively well. And you're just going to want to make sure that you get a nice feed right there, and you're going to crimp that in. Of course, you're going to need a crimping tool. Okay, so we have our cable here. Set that aside. We'll take these 10s out, we don't need them. $35. These are 25s. So top one in there first. It's got a magnetic connection. Get that one in there. Okay. And we need to turn it on so it begins to close. And what I found is it works a little bit best if you get this crimped in first, just so that it holds in place. Okay, so I'm gonna crimp the black cable now. I've just inserted the lug in here, and as you can see, I have it nice and snug in place before I've started to crimp it. And I have the bell end just coming out the end here as well. No jokes, guys. And I'm going to take the cut cable, so I have the insulation already peeled back on this. Insert the cable into the opening and just slowly start to crimp this. So I've got size 25 in here, and I'm crimping it down, holding the cable securely in place as I start to crimp that. All right, so that's holding now for me. And I'll just lock that down. So that's not going anywhere. So now all I've done is I've just opened it up a little bit and I've just pushed the bell end a little bit kind of further in. So I'm going to crimp that down now as well. You'll see it ends up kind of popping a little bit out the side as well, but we can fix that after. And make sure you have contacts between your two dies, and you can't close this anymore. That way you know it's a good connection. As you can see there, it's just popped that bit out the end there. That's okay. Don't need to worry about it. We can tap it down out of the way, or we can put it back into crimp and we can lock it down again. That's no problem. There we go. All done. All right. Now, of course, we have a little bit of kind of, exposed cable there. It doesn't really matter. I am, of course, going to put a little bit of heat shrink over there. But it doesn't matter that this little bit of cable is exposed, because it's going right into the battery connector, and part of the insulation is going to go in there anyway. So you're not going to see or be able to touch that exposed section regardless. Now, of course, when I originally cut these cables, I had a different plan in mind for them. So I'm not going to need these ferrules. I just wanted to show them in the video, because you might be using the ferrules to, let's say, connect them into a rotary isolator or a DC circuit breaker. So that's what you're going to use. You're going to use the ferrules to get those in there properly. You can put them in bare strands, but I'd recommend using the ferrules. They're the best job overall. If you happen to have a cable that already has ferrules on there, you're just going to want to cut those off. Job done. Make sure you get yourself a nice sharp cable cutting tool. Otherwise, it's a bit of a pain. So now that they're ready, I'm going to do the exact same on these ends. I'm going to put a couple of lugs on the ends, and that's going to allow me to connect both of the batteries together, daisy chaining them. And now that's all nice, well crimped, all set, good to go. Both ends of the black cable done. I'll just do the red one off camera, and then it'll be time to connect the batteries together. Okay, so back in place now, and I have the battery in place, and now it's time to get it connected. This is battery number 1, battery number 2. I'm going to be connecting these 25mm square or 4 AWG cables. And I also have a 2-meter Cat 6. So the job is going to be put the cables on this first, put the Cat 6 into line 2 or S485 2, and going from number 2 to number 1 here, and I'll be making the connections. Before I make any connections to battery number 1, I'm going to be powering down my Seplos unit here. And in order to power down the Seplos unit, I need to have my instructions to hand. So once you have your instructions to hand, it'll tell you exactly what you need to do. So it's going to say turn the AC rotary off, then turn the AC switch off, and then turn the DC off. I don't really have a lot of load going through the house at the moment, 0.5 units, so it'll only be off for a couple of minutes here, so I'm not really going to draw an awful lot from the grid, but just to be safe, I'm going to be switching off the unit. So I'm going to go get that done now. Okay, so as you can see, I've just connected the positive cable here. And the negative one is just loose. I'll tighten that up now shortly. Just wanted to show you the back here. Because this is version 3 BMS, the dip switches are going to all remain off. If you are using an earlier BMS or the version 2, for example, you don't get away with the dip switches. You do have to make changes to the dip switches. And I have my Cat 6 here now, so I'm just going to plug this into the outgoing, which is RS485-2. So I'm just going to connect that in there. All right. This is going to go into the first battery. So I'm just going to tighten this up off camera. I only have 2 hands, so I want to make sure I do this properly. And then I'll turn this off and make the final connections on this battery. Oh, I should also mention here that this first battery is bonded or earthed. So that's actually running into the consumer unit. It's running through here, through the back of there, all the way up through into the consumer unit in the main house. So I'm not going to be doing that this evening. It's getting a little bit late for the second battery, but I will bond that tomorrow. So I think it is important to earth it. But for now, just to make sure everything's working fine, I'll leave that until tomorrow, but I'll make the main connections now. All right, time to switch everything off. First, the rotary isolator, next the AC switch, and finally DC. Now, it's dark outside. It wasn't generating any DC anyway, but just to be safe, turned everything off. So now, just waiting for the unit itself to shut down. Okay, so I have everything connected here now. Basically what I did, I'll just run you through the process. This is battery 2, this is the second battery. I had actually made a little bit of a rookie error. As you can see, I had put the live color on the negative here. So I've just decided to, rather than open up the battery again and mess around with this, I'm just going to use the black cover. The black cable is on here anyway. So I've wrapped some additional insulation around the black cable here. So that, not at risk of touching that at all. And lock that in there. And here's the positive one back here. Same job again. You know, we have the negative color here, but I've just put the positive cover on the top. Right, now I did check up again. I was about to make a bit of an error. So this is battery 2. Battery 2, it actually goes into the RS485-1, so into the second port, into the middle port rather. That's where you want to put that. So they're all torqued down now. And over to battery 1. So all correct colors here. So again, positive to positive, and that's the correct color. Negative to negative back here. And the RS485, that's gone into port 2. So your first battery, you're going to go into port 485, the rightmost port when you're looking directly at it. So that's how you're going to do that. Now, ready to turn everything on. So to turn it off, we did rotary AC, switch, and DC. So we did 1, 2, 3. So we'll start with 3, 2, and 1. Now, it is fairly dark outside, so there is a possibility that we're not going to get any power. I have switched the unit off at night on a couple of occasions. If it's only off for a really short period of time, it tends to turn back on anyway when I was troubleshooting this logger issue. But it looks like we're not getting power here. So I'm going to give that a minute, see what happens. And if nothing happens, I'll supply power to the inverter with the battery. So both batteries are switched off at the moment. Yeah, okay, nothing happening there. Right, so let's switch on battery number 1. And this was at about 50%. So, right, that's turning on. and I'll turn on battery 2, which was at about 30%. It hadn't been charged up at all, so just switch. There we are, that's turning on, and there we are. So we have power to the inverter. Right, let's see what happens here. We've got can OK. That's good news. I suspect I would have having a can fail if I followed what I originally thought, which you know, putting the Cat 6 in the wrong positions. So I'll edit that bit out so you don't even make that mistake, or I'll cover it over with some text. All right, so we're at 40% overall battery. As you can see here, this battery is actually at 49%. And this battery is at 32%. So it's calculating the overall average of the batteries. That's great. So we've got good communication between the batteries, and it's being sent to the inverter. Now, this is just the solar itself kicking in or turning on. There we are. All right, I can see that the house is requiring 0.45. It's taking 0.55 from the grid. That's basically the difference between the house and the inverter. So the inverter is drawing that little bit extra. So let's see if the battery is going to start working. And there we are, perfect. The battery is now feeding the house. The current from the grid is getting smaller, and I'm sure the batteries will take over. Sometimes it takes a couple of minutes to kind of balance out after everything has been off, but that'll get smaller, and that will pick up the slack. And before we know it, we won't have anything coming from the grid at all. All right, so guys, that's it. 2 Seplos batteries hooked up, hanging precariously over the edge there. I'm going to sort that out now. And they're communicating, and I'm going to see how they charge overnight. So I'm not going to get these batteries fully charged, probably over the next 2 nights. I'm going to leave this on self-use, so the sun will charge them during the day if we do happen to have any sun. So hopefully by tomorrow night they'll be fully charged. I'll balance both of the batteries. I'll hit the active balancer on these once they're up around the 100% mark, and that'll be it. Everything will be good. Okay, so everything seems to be checking out fine. We have 40% here, state of charge, showing on the inverter. The battery is completely feeding the house, and there's nothing coming from the grid. So noting here that we have 40%. If we move to the first battery, our state of charge is 48%, and it's drawing around about 10 amps from that battery. And if we move to the second battery, we're coming in at just over 32%, and there's nothing been drawn from there. So between the 50 odd and whatever, the 30, you're averaging out at the 40%. No warnings on either of them. And nothing is being drawn from the second battery, simply because the state of charge is lower on the second battery. So once the first battery reaches a state of charge of 32.6, which it's now at 48.2, once they meet the same state of charge, well then both batteries will start to be drawn from the house. So what I expect is when I check this first thing in the morning, both of the batteries will actually be at the same state of charge. So I'll check that and add it into the video. So you guys, I'll see you in the morning. For you, it's going to be just a few seconds. Here we are the next morning. So it's 6:50 a.m, 87%. And I've just turned on battery 1. We're at 95% state of charge, and battery 2 is at 80.7. So they're a little bit closer together, but obviously they still need to sync up. They haven't fully charged. I didn't expect they would. So we'll see what they are like later on. As you can see, it's a little later on in the day. I've just come home from work. The battery has been charging from solar all day. Somebody's in the shower now at the moment, which is why we're drawing about 5 kilowatts and 0.8 kilowatts from the grid. So the house is taking 5.77 kilowatts at the moment. So onto battery number 1, we're reading 96.3% state of charge and 95.4 on the second battery. So they are more or less in sync now, just a percentage in the difference. So I would say that by tonight, or rather tomorrow morning, when they are charging up, they will balance off, and then I'll be able to top balance them with the active balancer. So guys, I don't think there's any need to wait until the batteries are 100% in sync with each other. They're basically only 1% off, and they're going to balance themselves over the course of the early hours of the morning. So this is how you connect your Seplos batteries together. I will be adding a third battery, I'd imagine, down the line, and I'll update the channel if and when that happens, I should say. I'm going to see how I get on with the 2 batteries. Now, whether you're connecting to a Seplos inverter, like I have in this case, or any other inverter, it's more or less going to be the same. Of course, you're going to have to adjust the settings on your inverter. You're going to have your comms port, and you're going to have your positive and negative to connect your batteries to. That's pretty much it. It's fairly simple. If I can do it, pretty much anybody can do it. I hope this has been helpful for people. I'm sure it has been helpful for people, and I hope that it continues to be helpful for people down the line. Now, whether you want to reduce your carbon footprint and or reduce your bills, I think this is a great idea, especially if you can charge your batteries on cheap night rate electricity, and if you have the additional benefit of expensive export at particular times of the day. Check out one of my other videos where I explain the settings on the Seplos batteries. So if you've got some value from this, please like and subscribe. I will be adding some more videos down the line. As I say, I'll most likely be adding an additional battery here, and I will be showing the building and completion of these cabinets when I get around to doing it. We're getting into the cold weather, so I really should get on with that and hopefully finish that in the next few weeks. So thanks for watching, and I'll see you in the next one.